Hello and welcome to lesson 3.9. Today we're going to look at the Pythagorean Theorem. And although this is kind of hard to read, our objectives are going to be able to solve problems using the Pythagorean Theorem and then to also be able to identify a right triangle. So when we look at a right triangle, typically a right triangle, if you're looking over here in the lower right-hand corner, a right triangle is often indicated by a little box in the corner. And that box just tells us that these two side legs are 90 degrees, or what we call perpendicular to each other. So in a triangle, you're always going to have the side that is opposite of that right angle. So that would be this side here. This is what we call the hypotenuse. And then we have the legs, okay? And the legs of the right triangle are what form the 90 degree or the right angle. So the Pythagorean theorem then is going to describe the relationship between the lengths of these two legs here and the hypotenuse. And this only applies with a right triangle. So by definition, the Pythagorean theorem says in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if you look at my legs, again, in this case are A and B because they're what make up the right angle. So if I take A and I square that and I add it to B squared, that's going to give me the length C squared. Now, if I need to find just the length of the leg or the hypotenuse, I may have to use a square root. And when we're talking about a real world situation, which we will do some of those in our examples, you only need to look at the principal or the positive square root because it doesn't make sense to have like a negative length. So let's go ahead and take a look at a few examples. For example 1, it says, what is the length of the hypotenuse of the right triangle? So notice we have our right angle here. I have side length 1 and side length 2, or leg 1 and leg 2. So the relationship, again, if you recall, is a squared plus b squared equals c squared. So when I go in and I plug in my numbers, I have 8 squared plus 15 squared equals c squared. When I simplify this, 8 squared is 64 plus 15 squared, this is 225, this is going to give me c squared. 64 plus 225 is 289 equals c squared. So what I have to do now though is I need to find just the side length c. Okay, so to do that, when I look over here at my equation, I see that I have a c squared. So to undo that square, I actually need to square root both sides. So when I square root a c squared, I end up with c. In the square root of 289, this is actually 17. So because the units on my other legs are in meters, I know that the length of c then is 17 meters. Example 2 says a fire truck parks beside a building such that the base of the ladder is 16 feet from the building, and you can see that right here. Then it says the fire truck extends its ladder 30 feet as shown. So this is my length of my hypotenuse. This here is the length that is 30 feet. We want to know how high is the top of the ladder above the ground. So ultimately what we're looking at doing is we're looking at finding this length here, and then we're going to have to add that 10. So to start out with, I'm going to write down my Pythagorean theorem, which is a squared plus b squared equals c squared. And in this case, I don't know what side length b is, but I do know that a is 16. So I have 16 squared plus b squared equals my hypotenuse is 30 squared. So if I simplify this, I have 16 squared, which is really 256, plus b squared equals 30 squared is really 900. So if I get b squared by itself, I'm going to subtract 256 from both sides, and I end up with 644. So again, I need to know what is b by itself. So I'm going to have to go ahead and take the square root of both sides, and I can see that b now is equal to 644 is not a perfect square, but I end up with 25.4. Okay, so that's this length again right here. So if this is 25.4 and I'm starting that ladder 10 feet off the ground, which as I can see from this length here, I know when it says how high is the top of the ladder above the ground, I'm going to have to add 25.4 plus 10, and I'm going to end up with 35.4, and that would be feet. And this here would be the final answer to this story problem. For my last example, it says use the figure at the right, and it wants to know about how many miles is it from the downtown to the harbor. Okay, so here's my harbor, here's the downtown, so I'm looking to find this distance right here. So again, I'm going to use my a squared plus b squared equals c squared. My hypotenuse, this is my c value, and then because this is already called b, we'll call this our a. So I have 4 squared plus b squared equals 8 squared, or 16 plus b squared equals 64. If I subtract 16 from both sides, I end up with b squared equals 48. And if I square root now, because I need to get b by itself, 48 is not a perfect square. It's in between 36 and 49. So I know that my number has to be somewhere in between 6 and 7, because the square root of 36 is 6 and the square root of 49 is 7. So if I punch this in on my calculator, I get about 6.9 miles. So that's how far it is from the harbor to downtown. And for our last example, we have to determine whether the given leg lengths can be the sides of a right triangle. So because the hypotenuse is always the longest side length, that will always be our c value. So in this case, this is my c value, so I just have to prove, does 5 squared plus 12 squared really equal 13 squared? So 5 squared is 25, 12 squared is 144, and 13 squared is 169. So does 25 plus 144 equal 169? And the answer is yes. Therefore, these are the correct leg lengths for a right triangle. Likewise, for the next part, 12 is my largest number, so I'm going to have 7 squared plus 9 squared, and I have to figure out if that equals 12 squared. So here I end up with 49 plus 81, and I want to know if that equals 144. Well, 49 plus 81 is actually equal to 130, so that's not equal, so these are not the sides of a right triangle. Please let me know if you have any questions. Otherwise, I will see you guys in class. Have a great day.